Okay, hello and welcome to this IUCN Red List webinar. My name is Janet Scott and I'm a Programme Officer in the Red List unit where I've been based for the last 12 years. Today we are going to hear from Professor Resit Akçakaya, the Chair of the Red List Standards and Petitions Committee. Resit was heavily involved in the development of the Red List categories and criteria and remains very involved in keeping the guidelines up to date and relevant with new developments. The purpose of these webinars is to provide some more support and guidance to all of you, members of the Species Survival Commission and others working on Red List assessments. This webinar is also being recorded and will be available on the Red List website afterwards. During the registration process, you had the opportunity to raise questions you would like to be addressed, and Resit will be answering many of these over the next 90 minutes. It won't be possible to answer all of the questions you posed, but for those of you who asked questions that are outside the scope of this webinar, I'm getting back to each of you with the response or with advice on which other resources you can consult. This webinar is primarily aimed at those who already have a good understanding of the categories and criteria and Red List terminology. So it won't go over the basics, which are covered in the online Red List training course. If you haven't yet taken the course, I would highly recommend that you do so, and I will post the link in the chat. You can also use the Q&A function to ask any further questions which arise during the course of the webinar. Please use the Q&A specifically for that rather than the chat. You'll see that both are available as options at the top of the screen if it's easier to keep things all in one place. For some of those questions that you ask, I'll provide a written response straight away during the webinar, and some others I will pass over to Resit at an appropriate moment for him to answer live. Finally, please note that this webinar will be repeated tomorrow, later in the day. We wanted to make sure that as many people as possible, based in a wide variety of regions, would be able to attend. Tomorrow's edition won't be an exact repeat, as it will cover slightly different questions which were raised by those registering for the other slot. But if you'd like to attend that one too, or to watch it afterwards when it's available on the Red List website, you're very welcome to do so. So thank you all for joining what promises to be a really interesting webinar. And without further ado, I'll now hand over to Resit. Thank you.
Hi, everyone. Thank you, Janet, for organizing this and also introducing while keeping admitting people. My name is Resit Akçakaya, and I'm here as chair of the Red List Standards and Petitions Committee of IUCN. But like most of you, my role in the IUCN is a volunteer one. My day job is as a professor at the Department of Ecology and Evolution at Stony Brook University, which is part of the State University of New York. Thank you for those who submitted questions. I selected the more specific questions to address in this webinar. I grouped your questions into a few headings. And after I cover the questions under that heading, I'll ask for any other questions or clarifications. Before I get to those questions, I want to remind you of 3 important resources for red listing, which you probably already know, but just as a reminder. First, there is the Red List guidelines that the Standards and Petitions Committee updates about every year or every other year. We are now in version 16 since 2001. So in 23 years, we had 16 versions. The Red List guidelines, of course, are explaining and providing guidance on how to use the categories and criteria, which is the main document for red listing. There is also the Red List online training course, and if you have not taken it, I strongly recommend it. And since earlier this year, there is also a another tool is Red List platform. That is an online platform that facilitates the assessment process by allowing you to estimate the parameters that go into SIS, such as area of occupancy, fragmentation, and other parameters. So if you have not checked it out yet, I strongly recommend that you take a look at that as well. Now, this is not, as Janet said, this is not an introductory webinar. It's not an introduction to Red List, but we do need to talk about a few fundamental concepts, even though they may seem obvious to most of, or they are obvious to most of you. So I'd like to start by reminding everyone about the purpose of the Red List, because some questions I receive and many misconceptions about the Red List are often related to its purpose. So the purpose, just to review it, is the classification of species according to their extinction risk. The purpose is not to list rare species or depleted species or declining species, or to list species that need protection, or create maps for conservation, or to determine conservation priorities. Obviously, Red List does help with the prioritization process, but as the categories and criteria say on its first page, it's not the sole means of setting priorities for conservation measures. Now, so I'll go ahead with questions and answers that are related to this topic. There are, I think, 4 or 5 of them. So the first question is the IUCN likely to consider genetic diversity when assessing species diversity? So the obvious answer is that I don't know whether IUCN assesses species diversity or will assess species diversity, but if it does, it won't be with the Red List, because Red List does not assess species diversity. Now, effects of genetics on extinction risk can be incorporated through the Red List Criterion E. And there was a related question about Criterion E, which was that whether we are planning to develop guidance on how to incorporate genetics into models in Criterion E. Obviously, there are PVA models that do incorporate genetics, but the way that my committee determines what to expand on in the guidelines have to do with assessments and questions about assessments that we receive. So if there are assessments that use Criterion E with genetics, then we will review them, and based on our experience and our review, we will consider adding further guidance into the guidelines document about that topic. Another question was about the problem of IUCN classification and research and conservation funding. Some species have been classified as least concern, but without threatened listing, it's difficult to get funding to start research. Now, again, Red List only measures extinction risk. Manipulating the extinction risk category for any reason whatsoever, whether to get funding or because we think it will protect the species better, is not done because it would harm conservation in the long run, because it will diminish the credibility of the Red List. So absolutely no changes to the Red List category because of whatever we might think will be the consequences of the Red Listing. Another question was, should the IUCN categories be focused solely on extinction risk when numbers are so low that species are not able to perform the same ecological roles that they did in the past? And another question kind of related is how to use the Red List status to determine the success of conservation efforts, the impact of our work. Now, again, Red List measures extinction risk, so it doesn't measure ecological roles. It doesn't measure conservation effort. It has one important role, which is to measure extinction risk. But extinction risk, of course, is not the only important metric in conservation. Also important are things like how far the species has declined from historical baseline. So how do we avoid the shifting baseline syndrome? Or to what extent the species performs its ecological role, which is the topic of the first question here. Or how much the species has recovered and how much of this recovery can we attribute to our efforts? What is the effect of our conservation efforts? And this is, of course, related to the second question. So Red List does not measure these, but all of these are addressed by the IUCN Green Status of Species, which is a new global standard that IUCN developed just a few years ago. It is a standard for measuring species recovery and assessing conservation impact. And the species recovery is measured based on three components of recovery, which are viability, functionality, and representation. So I won't talk anymore about the green status of species because it's a different assessment protocol, closely related to the Red List, but different. So I will, if you are interested, please look at this webpage and follow up. Okay. So these, any other questions about purpose? Next, I'll be talking about uncertainty.
Thanks, Resit. John Paul Rodriguez has just asked, are there any plans to develop criteria for extinct in the wild species equivalent to those for threatened species in the IUCN Red List?
Extinct in the wild. So there are criteria for listing species as extinct or as critically endangered, possibly extinct. So the same criteria are used for extinct in the wild. If the species meets those criteria but has a population in captivity, then it will be extinct in the wild. So I will actually cover those later in the talk about the extinct, what's it called, tool, Extinction Probability Tool. Any other questions?
Thank you. That's it for questions that have been asked at the moment.
Okay. So going on with uncertainty, that's an important topic and another kind of fundamental basic topic. But we all know that all data, all biological data are uncertain, especially when it comes to threatened species. So the way we incorporate uncertainty in Red List assessments is first enter all data, but enter the uncertainty about the data as well. So for instance, the estimated area of occupancy in SIS, you can enter as a range of values or as a range of values and a best estimate. And the best estimate itself can be a range of values. And the result will be a range of categories. In other words, we propagate the uncertainty in these data that we enter all the way to the species threat category. And the threat category, as a result, can reflect this uncertainty in terms of a range of categories. Now, there were a number of questions that are related to uncertainty. So, for instance, when are data poor species not data deficient? And when do we consider what do we need to consider when working with data poor species? What are the minimum data that can be used? So all of these questions, what you have to do is enter all available information in SIS with realistic uncertainty bounds. And there are extensive guidelines about this in the Red List Guidelines document. Then you use the SIS criteria calculator. The SIS criteria calculator will use the information and give you the Red List category as a range of plausible categories. If that range includes both critically endangered and these concerned, then the taxon should be assessed as data deficient. In other words, you don't predetermine whether you have too little data or too uncertain data to assess a species. What you do is you enter all the data you have with uncertainty bounds and let the SIS criteria calculator tell you the range of plausible categories and then decide whether it's data deficient or not. Another question was that if there are data for a species but not adequate for a stock assessment, should we consider that as data deficiency? No, definitely not. Stock assessment is a different process. It's not a Red List assessment. There may be situations where you cannot know the population size, the current stock or the current abundance, but you may know other information such as range area or trends in an index of abundance that will allow you to assess a species. So you use the same process as outlined here. A more complicated question is how to assess a widespread species with few and very small populations. So I have two answers for that. The general answer is the same as before. Always enter all available information into SIS with uncertainties, use the criteria calculator, and do not predetermine which criteria to apply. Now, in this particular case, I think that for widespread species with few and very small populations, because the populations are few and small, number of mature individuals will be important, both the total number and the number in the largest subpopulation. In other words, in other parameters, what would be important probably is the area of occupancy, severe fragmentation, and location. And we'll talk about severe fragmentation and location a bit later. But also, of course, consider all other data, especially if there are any information related to declines and reductions. And I'll talk about the declines and reductions next. But first, are there any questions related to uncertainty and data deficiency?
No one has asked any questions related to uncertainty or data deficiency now. Thanks.
Okay, thank you. So reductions and declines. There are multiple parts of the Red List categories and criteria that are related to reductions and declines, and I try to organize these in this table. So first, there is continuing declines, and there are two types of them. Under criteria B or C2, there is continuing decline that is entered only as a true false. In other words, is there continuing decline or is there not? And under C1, there is estimated continuing decline that's entered as a percentage, right? A separate type of decline is a reduction under criterion A, which does not have to be continuing. It may have already stopped, but it is still considered under criterion A. It is also entered as a percentage. The timing is different for these three categories. And also important that there are additional conditions. For example, for continuing decline under B or C2, there are additional locations, fragmentations, or mature individuals that have to be met for that criteria to contribute to the extinction risk. Under C1, there is number of mature individuals, and importantly, under criterion A, there are no additional conditions. So there's only the reduction that is considered. Now, this is a complex topic, so I won't go into the details of this a lot, but there are different sections in the red list that are related to reductions and declines, and these sections are updated frequently, so I encourage you to check those. Now, there were a number of questions related to how we project population reduction under criterion A3 and A4. Now, A3 is about future reduction and A4 combines future reduction with past reduction, and they both require projection or predicting what will happen in the future, which is always, of course, a complicated thing. So here are some examples of how we can do that. So one way is to extrapolate the current decline. If there is information that leads you to infer that threats are not decreasing and that are not likely to decrease in the future. In that case, it is legitimate to extrapolate the current rate of decline statistically to say that if there has been X percentage decline in the last one generation, we expect a similar percentage decline in the next one generation. Another way is to use demographic models to project reductions, and there are extensive guidelines about how to develop demographic models that are acceptable for red list assessments. Another way is to use disease models to project reductions of the species that are impacted by the disease, and I'll mention this in the next slide. There are also bioclimate models that can be used to project species decline based on projections of climate change, and I will talk about these in a bit later. We can also infer reductions based on observed reductions in part of the range under particular threats and assumptions or information about future spatial scope and intensity of these threats. In other words, you know that one part is affected by a certain threat and the species have undergone a certain amount of reduction in those areas under those threats. If you have information about those threats expanding to other parts of the range of the species, you can extrapolate, assuming that the species will respond similarly in the other places which are not yet under threat but are expected to become under threat. So that's called inference, which is different than estimation, and the differences between inferred, suspected, and estimated and projected declines are discussed in the guidelines. We can also suspect reduction based on the responses of other species with similar life history and responses to similar threats. So that is a lower level of data quality to a suspected decline, but it can be used when we have information that species with particular life histories respond in a particular way to threats that are expanding in the range of the focal species. Now, an important thing about criterion A4 is that usually it's difficult to project reductions in the future for 3 generations, which is required under criterion A3. But you may be able to project reductions for 1 generation. And then you can combine it with past reduction of 2 generations of the species to calculate a 3-generation reduction under A4. That allows you to use a smaller projection window, which will result in more increased confidence in the projection, and also go back only 2 generations, not 3 in the past, so that you can use more recent data. That combination is very useful for those cases. So one question related to reductions was about an impact of diseases, specifically avian flu. I don't know much about avian flu, so I cannot really talk about it. But one thing that I can say is that if its disease is spreading, then the important information to collate will be the rate of the spread of the disease and how that rate is variable from year to year, to collate information on current locations where the disease is detected, and assess the probability of occurrence at a new locality. In other words, what's the risk that humans will spread the disease to new places, and also the species immunity or susceptibility to disease. Now, after you collect these, you can see if the methods we used in a recent paper on a fungal disease affecting salamanders in Europe may be applicable to your case. And the URL of this is here. Janet will be putting that in the chat. This paper includes Excel spreadsheet template for applying this sort of information to criterion A3, D2, and criterion E to assess species according to these 3 Red List criteria. Okay, so any questions about reduction and declines? Next, I'll talk about climate change.
There was one written question about reductions, but I've already answered that in the Q&A function.
Okay, thank you. Okay, climate change. Now, the climate change is covered in the Red List Guidelines section 12.1, and this section was revised in March of this year. To revise the section, we asked 15 climate change modelers to help us, and this resulted in substantial change to sections on using bioclimate models. These are also known as species distribution models, SDM, or ecological niche models, ENM. And in the Red List, they are used to infer population reduction and continuing decline. Now, again, based on the input from these climate modelers, we also devised a new template for model description. And I'll briefly go through the contents of that template that is now required for supplementary material that accompanies assessments that use climate change models and bioclimate models. So the first group of information is very basic in this supplementary information file. It's the taxon, the author's date, etc. Then the information is requested about the occurrence data or the species data, which is the response variable for bioclimate variables. So as any statistical model or statistical method, the bioclimate models require a response variable and explanatory or predictor variables. The response variable is the species data, and species data comes in 2 categories. One is the occurrence data, and the other one is background or pseudo-absence data. And there is information about each of these types of data that we need in order to evaluate if the model meets the standards. And these are described in this template file as well as, of course, in the guidelines. I won't go into the details of this, but if you have done any species distribution modeling, or like with Maxent or random forest or similar methods, all of these will be quite familiar to you. As I said, the other type of variable data that is required by any statistical regression type of model is predictor variables. And in this case, there are climatic variables that are predictor variables and non-climatic variables. Again, the template asks details of how you obtained these data and where they came from and time points, etc. And then there is information about the actual model that is used, like the modeling approach, which is, for instance, Maxent or random forest or regression or whatever else, and other details of the modeling, and then how you use the results to calculate the red list parameters and the references. So these are the headings for the supplementary information. And now this is a complex topic. Obviously, if you have not done such modeling before, it will be quite difficult. We realize that. So the climate change specialist group is trying to develop a facility in which the specialist groups who want to make red list assessments of species under climate change will be assisted by climate modelers through the climate change specialist group. So if you have a need for expertise and you think you have the data that's necessary for bioclimate modeling, I encourage you to contact the climate change specialist group and ask if they can assist you. Any questions about climate change?
No one has asked any questions about climate change, no.
By the way, if you, after we complete a topic and go on to another topic, if some other question occurs to you, just write it in the chat, because at the end, if there is time, we will cover other questions, whatever questions you have. Okay, next, inferring extinctions with the Extinction Probability Tool. This is a rather new addition to the guidelines since about 2019 or 2020. I'm sorry, 2020. Because of that, I want to just briefly mention it. What we mean by inferring extinctions is to determine if a species is extinct or critically endangered, possibly extinct. Now, as Jean-Paul asked earlier, there is also extinct in the wild and critically endangered, possibly extinct in the wild, which are also categories. They are also covered with this tool because if a species is in captivity, then you would use this tool with the wild population. And if this tool says, based on the wild population, it's extinct, then you would assess it as extinct in the wild. So this tool basically consists of a spreadsheet and an R script, and I'll come back to them. But first, let's review what information is necessary. So this is the definition of extinct based on IUCN Red List categories. A taxon is extinct when there is no reasonable doubt that the last individual died. A taxon is presumed extinct when exhaustive surveys in known and expected habitat at appropriate times have failed to record an individuals. So really the critical part of this definition of determining and of the process of determining when a species is extinct is whether the surveys have been exhaustive or not, right? Because just not seeing a species for, let's say, 10 years or even 50 years is not sufficient to call it extinct, because if you have not looked for that species at all, then you don't know whether it's extinct or not. So how do we know when the surveys have been exhaustive? There are three types of information. One is the area surveyed, what proportion of the habitats, species habitat was surveyed, and whether it was surveyed in the correct time of year, etc. The second one is difficult. This is the probability that the species would have been recorded in the area surveyed if it were present. This is a subjective probability that the assessor has to enter, and it will be a small number for a species that is cryptic and difficult to detect, and it will be a higher number for a species that is obvious and easy to detect if it is present. And the third one is the probability of correct identification. If the species would have been identified correctly when it is recorded. And this is going to be a small number for species that are very similar to other species, and will be a higher number for species that are unique in morphology and that are easily identified. But also will be a high number if advanced techniques such as DNA detection have been used in surveys. So once you know these three quantities, the area surveyed, the probability of detection if it is present, and the probability of correct identification if it is recorded, then you enter this information into a spreadsheet. So the guidance and examples for these three quantities are given in the news section 11. And there's discussion and guidance of how to incorporate threads. And there's a program to calculate the probability and guidance on how to interpret the results. So there's a spreadsheet template that you enter the information based on the quantities that I mentioned. So it has these three tabs: threads, records, and surveys that you have to enter. Records is when was the species actually recorded, and surveys is when species was surveyed but not recorded. And based on those, then you run this R script, and then this is actually, even if you have not used R before, it's actually quite simple. All you have to do is specify the species name and where this file is, and then run this. And what this program does is gets the information from this file, calculates it, and outputs this figure and these numbers. And these are the probabilities that the species is extinct based on two different models. And these are explained in the guidelines and in multiple publications. And based on those, if the species is in this corner, then it is considered, or it is recommended, that you list it as extinct or extinct in the wild. If it is in this upper right quadrant, then it is recommended that you list that species as critically endangered, possibly extinct, or possibly extinct in the wild. And if it is in need, is not in this upper right quadrant, then it is recommended that you list that species as threatened. Again, I won't go into the details of this, but there is extensive guidance and publications about this. There is also a Shiny app that implements this method. If you don't know what a Shiny app is, it's basically a user interface that makes it really easy to use this R code. I'm not going to recommend this now. I'm not going to put the URL because I haven't actually tested it. It looks promising, but because I didn't actually test it myself, I don't feel comfortable recommending it. but soon it may be possible to actually use this code with a much easier user interface. Okay, any questions about extinct, possibly extinct, extinct in the wild?
No, there have been a couple of questions asked on location and subpopulations, but that's the section we're going to get onto next, I see.
Yes.
So let Resit cover location and subpopulation, and if you have any remaining questions on those topics, please put some specific details in the chat or in the Q&A. It seems some of you can't access the Q&A. I'm sorry about that. Don't know why that's the case. So if you do want to ask a question in the chat, I'll try to get to both of those. Okay, thanks.
I see that there are some questions in Q&A. I'll get to them as well at the end. Okay. I think we'll have sufficient time. So there were a number of questions about locations, but a lot of them were not very specific. So I tried to make some general comments about locations, and we'll see if there are more specific questions. But one question was, when assessing a subspecies, what terminology we use, subpopulation, occurrences, locations, and another question about how to count locations for mobile organisms. First of all, whether it's a subspecies or a species, the terminology is the same. And these three terms are completely different from each other. An occurrence is a single locality where the taxon's presence has been recorded. And this is often, a specific geographic coordinates. That is what an occurrence is. And it's used in the red list and sites of occurrence in the definition of extent of occurrence or area of occupancy. And occurrence points are also used in species distribution models. Subpopulation is defined in the red list as a biological population of the taxon, and is defined as a geographically or otherwise discrete group that has little exchange with similar groups. And the definitions and explanations are in section 4.2 of the guidelines. Location is very different from this. It's a geographically or ecologically distinct area in which a single threatening event can rapidly affect all individuals. So I'll get to this in more detail now. Now this is the definition that I just read. I think it's better to think of location as area of threat. And I wish that in 1999, when we were revising the criteria, we actually renamed it as area of threat as opposed to location, because it is leading out to a lot of confusion, because the way it is used in the red list is very different from the general notions of location and locality. So I encourage you to think of it as area of threat, not as location. Now, why is it used in the criteria? It is actually a metric of risk spreading, similar but somewhat different than the aspects of risk spreading that are covered by area of occupancy and extent of occurrence. Basically, the risk spreading means insurance against spatially explicit threats. If a species has multiple locations, that means it's under the effect of different threatening events. Therefore, it is under less risk because the risk is spread to multiple locations. Basically, that's the meaning of location in the red list. Now, important thing is that if there are no threats, sub-criteria based on locations are not met. So you cannot say if there are no threats, then number of locations is 0. It is not 0. Number of locations in that case is basically, well, I'll come to that, how to determine number of locations. when some part of the range is not under a threat. But basically, if there are no threats anywhere in the range of the species, you have to assume that the sub-criteria that uses the term location are not met. Now, if parts of the range of a species are not affected by a threat, you can use one of these four options. One option is don't use location at all, meaning that assume that criteria that refer to the number of locations are not met. This will be appropriate only if the unaffected area is a very large part of the taxon's range. In other words, there are some threats, but they are only in a small part of the species range. In that case, you may just not use location at all, assume that number of locations is large enough that it doesn't meet any of the sub-criteria. Another option is that the number of locations in the unaffected areas is set to the number of subpopulations in those areas. And the thinking here is that each subpopulation is potentially its own risk area because of demographic stochasticity or allele effects or other demographic processes, putting those species at independent risk in different subpopulations. Therefore, each subpopulation can be considered a separate location, especially if subpopulations are small. Even if they are not under threat, if they are small, then they can go extinct because of demographic stochasticity, so they can be considered as locations. Another option that can be considered is number of locations is based on the smallest size of locations in the currently affected areas. So part of the taxon's range is affected by certain threats, and in those areas there is, let's say, the smallest area is 1 square kilometer. Then in the unaffected area, you say 1 square kilometer, each 1 square kilometer of the unaffected area is one location. This is only suitable if the unaffected areas are not completely insulated from threats, that they can actually experience these threats in the future. In that case, you can use this method. And similarly, in those cases, you can base the number of locations on the most likely threat that may affect the currently unaffected areas in the future. So this is when, part of the range is unaffected by any threat. Now, one thing that is usually confusing about locations is that locations are based on not the whole area that is affected by that type of threat, but by a single threatening event. And there are examples of these in the guidelines. I encourage you to read those examples. And if your case is not similar to any of the examples in the guidelines, please send me the details of your case so that we can add other examples in the guidelines that cover different types of situations. So now questions about locations.
There was a question about threat, trade as a threat. And I think the question is how you would calculate the number of locations if the main threat is collection, and what counts as a collection event in that case.
That's a very good question. So the way I would think about it is that the collection as a threat, what would make it worse or better? What would make it worse or better is a combination of conservation measures or regulation that is on the ground and the demand for that collectible, right? If if some areas are better monitored and patrolled and protected, then those areas, and they are under different jurisdictions, those should be counted as different locations, because what would change the threat level and how much the species is affected by the threat is the level of level of control and monitoring and prevention. However, if there is none of that on the ground, then the threat would be determined mainly by market forces, whether there is, whether that item is fashionable or not, right? In that case, the number of locations will be based on the number of markets. So if there is, one market in one continent that values one aspect of that thing, and in another place it's valued for some other reason, and there's a different market for it, then it will be two locations, right? So then the locations will be determined based on the markets. I don't know whether the specific case is, related to this, but that is the sort of way to think about, I think, traded species. Other questions?
Thanks, there hasn't been any more comment on that. So for now, let's assume that you answered that question. In the meantime,
are people able to raise their hands to?
There is a raise hand function.
Okay, so continuing with the last topic, which is severely fragmented, there was not a question on this, but it is a topic that is frequently misunderstood. So I thought that I'll quickly review this. Severely fragmented means that most individuals of the species are in small and relatively isolated populations. So the first important thing is that this is about population fragmentation, not habitat fragmentation, but population fragmentation may be inferred from habitat information. The second important thing is that there are two important terms here: small and isolated. Small means that it is not viable. In other words, the population by itself, without dispersal from other populations, would not last long. And the other term is isolated, which means that the species is not connected by dispersal to other populations. And if it is extirpated, there is a very small probability of recolonization. So what is small? There is an expanded section in the guidelines, starting with version 15, about how to interpret this. I will not go into the details, but some people have asked if the concept of minimum viable population is applicable here. It is not applicable. But in general, for most species, a population size in the low tens should be considered too small, in other words, not viable. And a population size in the hundreds is probably large enough and should be considered viable. So it's between those two that you should consider the species to be viable or not. And then there are other evidences that you can use. If a population has persisted for a long time with X number of individuals, then that's an indication that that can be used as a threshold. You know that that is a viable number in that case, right? And if there is continuing and sufficient recruitment in a population of X mature individuals, then again, that's an indication that that is a viable number. What is isolated is is a bit complicated because the definition of subpopulation already says that it has limited dispersal, right? Limited genetic or demographic connectivity. Isolated population means that it has even less connectivity. It's too far from other populations for recolonization to occur with a high probability. And the evidence to use will be dispersal distances, dispersal ability of the species, and dispersal ability of similar species. Now, I want to mention again the Red List tool here because it has a part of it that allows you to estimate severe fragmentation based on assumptions that you enter. And I want to just give some examples here. So first case is that you have this fragmented map of habitat fragmentation, right? In this case, because you only know habitat fragments and not populations, you have to say that severe fragmentation is unknown. It can be based on habitat fragmentation, but there has to be some information about populations. Now, suppose we have some guesses. These don't have to be exact numbers, just guesses of number of mature individuals for each of these fragments. Again, you have to say severe fragmentation is unknown because we don't know what to consider a viable population, right? Now, suppose you decided based on the type of information that I just reviewed that a number of individuals, about 40 individuals, would make a population viable, right? So you decide that that's a good threshold. In that case, this species would not be severely fragmented. Why? Because if you add the viable populations that are 140, their sum is more than the populations that are not viable, which are 30 and 15 and 25. So there are 70 individuals in not viable and 140 in viable. That means most of the population is not in small and isolated populations. A minority is, so it's not severely fragmented. Now, if instead viable population threshold is 50 mature individuals, then this is also not viable. So the number of individuals in viable populations is 100, and the number of individuals in non-viable populations is 15 plus 30 plus 40 plus 25, which is 110. So most of the population is in isolated and not viable populations. Therefore, it is severely fragmented. However, if there is dispersal between these two populations, again, it's not severely fragmented because this is connected now. It's not isolated. So the number of individuals in small and isolated populations is 95, and it's less than half, and therefore it's not severely fragmented. Two other clarifications. A taxon with a single subpopulation can be severely fragmented, but for that to happen, that subpopulation must be too small to be viable, right? So in that case, it will be severely fragmented. Of course, in that case, the taxon is likely to meet criterion D as well, but just for completeness, it's important to state that it's severely fragmented. But if the single population is large, it is not severely fragmented. A taxon with two subpopulations can be severely fragmented only if they are isolated from each other and both are too small to be viable, right? Because if they are not the same size, and if the larger one is large enough to be viable, then it's not severely fragmented because most of the individuals is in the viable population. Or if they are not isolated, then it's not severely fragmented. And finally, the severely fragmented and location are independent concepts, even though they are sometimes confused. A taxon may be severely fragmented, yet all the isolated subpopulations may be in one location, right? Because they are threatened by the same factor, even though they are different subpopulations and they are isolated and severely fragmented, it will still be a single location. But each subpopulation may also be threatened by a different factor, in which case there will be multiple locations. Also, note that location requires a threat, but severe fragmentation does not require an ongoing threat. Whether there is a threat or not, as a taxon can be assessed as severely fragmented. Any questions on what I just presented on severely fragmented?
I'm not sure it's directly related to severely fragmented, but it's sort of tangentially related. That somebody has asked if there's a group of individuals in a region reproducing, but separately in another distinct region, there's just
one second. I couldn't follow from the start. Can you?
Once again. So there's a species which has a group of individuals reproducing in a region. It's a subpopulation. And separately, somewhere else, there's just 2 or 3 individuals which aren't reproducing. Should they be considered as a separate, should they be considered as a subpopulation, or if there's no reproduction ongoing, can they be essentially excluded from the assessment?
No, they are not excluded from assessment. Reproduction is not a required.
So as I understand it, in this case, there would be
it will be a separate subpopulation.
It's a separate subpopulation, but this one would be small enough to be count as not being viable in the long term.
Yes.
But that wouldn't necessarily mean that it's severe fragmentation. If the larger one has the majority of the individuals, and if that one is viable in the long term, then that wouldn't count as severe fragmentation.
That's right.
There haven't been any other questions asked about severe fragmentation. There has been another question come in location in the meantime. Would you like to cover that one at the same time?
Yeah, sure.
Is harvesting of aquatic species considered a single location, i.e. the same threat? This is kind of the same as the one we had before.
Yeah, again, harvesting, whether it's aquatic or terrestrial, doesn't really change it. The harvesting of species, the location should be based on the 2 factors that I mentioned, which is what drives the demand and what regulations are in place to regulate the harvest. If there is only one jurisdiction and only one, agency determining regulation, and there is only one market where the demand for the aquatic species is determined, then I would say that that is a single location. However, if there are different markets, for instance, there's a local market and there's an export market, and they are not correlated. In other words, one can increase, one can decrease. Demand can increase locally, but not for the export. In that case, it can be considered 2 locations. If there are multiple jurisdictions for the different stocks of the species, then it can be considered multiple. Each jurisdiction can be considered a separate location because the regulations and the enforcement of regulations will be different. Okay.
I think that's it for questions on severe fragmentation and location. Thank you.
Okay, so actually that's all I have. So we can go to all other questions. And by the way, don't forget these 3 resources. So any other questions?
Someone did ask if there was a good example for a species assessed on the basis of climate change. What was the question?
I don't actually follow all the assessments, but there are so all coral species were recently assessed, and many of them are affected by climate change. They did not actually use the ecological niche models of the type I mentioned, but they used a different approach that is kind of experimental. We'll see how it is reviewed, but it is a pragmatic approach. Coffee Arabica, the wild version of the coffee that is cultivated, is assessed some years ago, and they used a very well-developed ecological niche model for that. So I encourage you to look at that. The cacti and succulents group has assessed climate change impacts on species in a publication. I don't know whether those assessments are reflected in the Red List yet, but I read the paper that they published, and that looked like a very good application of species distribution models as well. So those are the ones that I remember.
Thank you. There's also been a comment that for marine species, illegal, unregulated and unreported fishing is a big threat, and that can be difficult to account for in terms of calculating the number of locations.
Can you repeat the first part? What is the threat?
Illegal, unreported and unregulated fishing.
Okay, so if it is illegal and unreported, then obviously what I said about regulations and jurisdictions are not relevant. In that case, locations would be determined by whatever drives the demand. And however different sources of, points of demand there are, that should determine I would think the number of locations, which is actually a strange thing. I haven't thought about this that well. I'm just thinking on my feet here. So let me not answer that question definitively. Let me consider that and ask the Standards and Petitions Committee about it, because that is a difficult case. Can I ask you, please, whoever asked that question, send me a bit more detailed description of what drives the demand for that species, and that will help me think about this case.
Thank you. Yes, and if you can't find Resit's contact details, then email me in the Red List unit, and I'll pass it on. Apparently, the question was specifically sea cucumbers, international markets to meet Chinese demands.
Okay.
But we might still need some more details. In terms of other questions, I think we've covered.
So I'm going to read a few additional ones that I find interesting. So one question says, criterion A mentions a time span of 10 years or 3 generations, whichever is the longest. If data for a longer time span is available, can we use that for the assessment? Yes, but please see the guidelines. So the way that works is that, yes, you use as much data as you have that is reliable, but you always calculate based on that the tree generation reduction. In other words, let me actually try to show it if I can. I don't know whether I will be able to do this. Okay. Do you see this in the correct direction?
It looks good to me.
Okay, so here is population size, and here is time, right? And you have some data, and you are looking to see the reduction, and let's say the maximum of 3 generations and 10 years is, let's say, 20 years. And this is the 20-year, this is the 3 generation period here, this part. That doesn't mean you use only these data and ignore these data. What it means is that you use the whole data, but calculate the reduction only for the 3 generation part, the more recent 3 generation part. So you can use more data, but you have to use only the most recent 3 generations when calculating the reduction.
Great, thank you. Yeah, I attempted to write that in text, but the visual representation, I think, is far more valuable. I'm not seeing any more questions that haven't been addressed. Has anybody got any last questions?
I see that you have already answered all of the questions. That's great. Thank you.
Okay, in which case I think we may as well wrap up a little early rather than wait for any more questions if you don't have any more questions. So thank you very much, Resit, and thanks to all of you for attending and posing some interesting questions. Oh, there has been one more question asked just now. How to go about point endemics? I don't know really what you mean about point endemics.
Well, because the red list is about global assessment, endemics or not endemics are assessed exactly the same way. There is no difference whatsoever between endemic species or non-endemic species in terms of their red list assessment.
Thank you. There's also been one more question asked about the sea cucumbers, that they can't calculate a generation time for that because they don't have data, and how can they move beyond that?
Well, you mean no information on generation time? There's definitely generation time. All species have generation time, but I don't know anything about sea cucumbers, so I cannot really answer. But in general, there is always some demographic information about, age of first reproduction or anything about the life history of the species that allows you to, make a educated guess. Any guess is better than not using criterion A at all because it's an important important criterion. So what I recommend is that you look at all demographic information about the species and never search for generation time or generation length, because no one says those words. Always look for specific components of how you calculate generation time. So look for age of first reproduction, lifespan, all other terms that are used, and that's the way to go about it.
Great, thank you, Resit. So I think that's all of the questions answered. So let's wrap up here.
Okay.
Thank you very much, Resit, and thanks to all of you for attending and for posing some really interesting questions. This webinar series will continue early next year, when we'll have sessions on how to get the most out of the Red List website, because there's a lot more data and functionality there than lots of people realise. Yeah. And on what we check in Red List assessments after they're submitted to us in the Red List unit, and therefore how to make sure that you don't hit any hiccups or delays in the publication process. We'll circulate the dates and details of those webinars as soon as they're confirmed. And again, each webinar will run at 2 different times, just like this one. And if you'd like to attend tomorrow for the repeat of this webinar, then you're more than welcome to do so. All that remains now is to wish you all a good morning, a good afternoon, good evening, or good night, depending on where you joined from today. Thanks again, Resit. Thanks, everyone, and goodbye.
Bye-bye.